Teleportation or teletransportation is the theoretical transfer of matter or energy from one point to another without traversing the physical space between them. It is a common subject in science fiction literature, film, video games, and television. Since 1993, teleportation has become a hot topic in quantum mechanics, namely state, energy and particle teleportation. Etymology: the use of the term teleport to describe the hypothetical movement of material objects between one place and another without physically traversing the distance between them has been documented as early as 1878. American writer Charles Fort is credited with having coined the word teleportation in 1931 to describe the strange disappearances and appearances of anomalies, which he suggested may be connected, as in the earlier usage. He joined the Greek prefix tele, meaning distant, to the root of the Latin verb porta, meaning to carry. Fort's first formal use of the word occurred in the second chapter of his 1931 book Lo. Mostly in this book one shall specialize upon indications that there exists of transportary force that I shall call teleportation. I shall be accused of having assembled lies, yarns, hoaxes, and superstitions. To some degree I think so myself. To some degree, I do not. I offer the data. Fiction. The earliest recorded story of a matter transmitter was Edward Page Mitchell's The Man Without a Body in 1877. See also the movie The Fly, 1958, and 1957 story of the same name, in episode 20 of the Jerry and Sylvia Anderson children's program, Fireball XL5, produced in 1962 before the advent of Star Trek and its transporter. The Newtopians have a matter transporter used to dematerialize and rematerialize people between the planet and an alien ship, not unlike the later transporter of Star Trek fame, in the Star Trek Transporter, which brought the concept of teleportation into popular knowledge. Two essential stages of the process are dematerialization and rematerialization, created in an era before any CGI was possible. The visual effects communicating these processes to the spectators were created by dropping tiny bits of aluminum foil and aluminum perchlorate powder against a black sheet of cardboard, and photographing them illuminated from the side by a bright light. In the studio lab, after the film was developed, the actors were superimposed fading out and the fluttering aluminum fading in, or vice versa. Quote, according to an informal survey carried out by Lawrence M. Krauss on his campus, the number of people in the United States who would not recognize the phrase, "Beam me up, Scotty," is roughly comparable to the number of people who have never heard of ketchup. Quote, in his book, The Physics of Star Trek, after explaining the difference between transporting information and transporting the actual atoms, Krauss notes that the Star Trek writers seem never to have got it exactly clear what they want the transporter to do. Does the transporter send the atoms and the bits, or just the bits? Quote, he notes that according to the canon definition of the transporter, the former seems to be the case, but that definition is inconsistent with a number of applications, particularly incidents involving the transporter, which appeared to involve only a transport of information. For example, the way in which it splits Kirk into two versions in the episode The Enemy Within, or the way in which Riker is similarly split in the episode Second Chances. Krauss writes that in order to dematerialize something, in order to achieve matter teleportation, the binding energy of the atoms and probably that of all its nuclei would have to be overcome. He notes that the binding energy of electrons around nuclei is minuscule relative to binding energy that hold nuclei together. He notes that, if we were to heat up the nuclei to about 1,000 billion degrees, about 1 million times hotter than the temperature at the core of the Sun, then not only would the quarks inside lose their binding energies, but at around this temperature, matter will suddenly lose almost all of its mass. Matter will turn into radiation. Or, in the language of our transporter, matter will dematerialize. In energy units, this implies providing about 10% of the rest mass of protons and neutrons in the form of heat. To heat up a sample the size of a human being to this level would require, therefore, about 10% of the energy needed to annihilate the material, or the energy equivalent of 101 megaton hydrogen bombs. Quote, Scientists believe it is not possible to teleport macroscopic objects such as human beings, but there may be teleportation in the microscopic world. 3 possible kinds of teleportation in quantum mechanics and quantum electrodynamics have been proposed: state teleportation, energy teleportation, and particle teleportation. In 1993, Bennett al. proposed that a quantum state of a particle could be teleported to another distant particle, but the two particles do not move at all. This is called state teleportation. There are a lot of following theoretical and experimental papers published. Researchers believe that quantum teleportation is the foundation of quantum calculation and quantum communication. In 2008, M. Hotter proposed that it may be possible to teleport energy by exploiting quantum energy fluctuations of an entangled vacuum state of a quantum field. There are some papers published but no experimental verification. In 2016, Wei proposed that particles themselves could teleport from one place to another. This is called particle teleportation. With this concept, superconductivity can be viewed as the teleportation of some electrons in the superconductor, and superfluidity as the teleportation of some of the atoms in the cellular tube. Physicists are trying to verify this concept experimentally. See also: holodeck, replicator, Star Trek, wormhole, warp drive, Nightcrawler, comics, Azazel, Marvel Comics, warp, gaming, teletransportation paradox, Kestrel, Marvel Comics, Philadelphia experiment, quantum teleportation. Further reading: David Darling, 2005. Teleportation, The Impossible Leap. John Wiley & Sons. ISBN 978-0-471-71545-0. Lawrence M. Krauss, 1995. The Physics of Star Trek. Basic Books. ISBN 978-0465002047. Eric W. Davis, 2004. Teleportation Physics Study. Air Force Research Laboratory AFRL/PR EDTR 2003-20034. Bernd Staller, 2005. Advanced Visual Quantum Mechanics. Springer. 4.3.3 Classical Teleportation is Impossible pp. 170-171. ISBN 978-0-387-27127-9. Will human teleportation ever be possible? Human teleportation is far more impractical than we thought. Wei, 2016. How to teleport a particle rather than a state. Phys Rev 93. 066103.